Hello? Continue part 2, day 7, learning Godot. Second stream in a same day. Let's go. Now coding the player. Setting up project, create new player seed, player animation, coding player. Let me just see what's going on there. In this lesson, we'll add a player movement animation and set it up to detect collisions. To do so, we need to add some functionality that we can't get from a built-in node. So we'll add a script. Functionality can't get from with built-in node. Can't get with built-in node. We'll see about that. Add the script to a root node player. Playa. Playa. Anyway, shout out to Game Dev Doggy and Abhi Patel there on YouTube. Just for anybody who's here like a first time, I do multi-stream, so we are also here having family on the Kick, D-Live, Trovo, Twitch. And this time most lively crowd on YouTube. Didn't expect that. I'll add the script. I've got it. Script window, you can have a default settings alone, just click create. Skip the C# stuff. Inherit area 2D. This is your first time encountering GD script, read that. I've done that, don't worry. Start by declaring the member variables these objects will need. Export speed 400. How fast the player move pixels per second. Screen size of the game window. Okay, speed, screen size. Variable screen size set uninitialized. Should that be vector 2D? Vector 2D 0 maybe? How about that? So, Willy Ederson. Thanks for the follow there on Kick. Whitley Dereser 876. Really appreciate that. Great to have you here. Let me save all this. And this thing also. Root node, attach script, default. Ready process. Something's fishy here. Add attach a script. Create. They didn't suggest empty object, but inherit. Okay. Extend character to the body. And here, look, this guy has a jump velocity and speed. Hey, but not using this. Not gonna use it. Default omitted, or whatever is the spelling of it. this like this. I do it my way. Thank you for the tip. Physics process delta. Move and slide. How much of this stuff there is? Player script. I've got also quite a, no, this is the, hey, show me the, okay, player G, so almost blank. What I need is to add the speed and screen size. And export member or expose speed and local variable screen size. Speed export, okay, like that. So for the export var speed equal, what was the int 400, was it integer, come on, integer, full int, come on, don't like that, like this, yep, like this, like this. Okay, so keep the magnifying viewport in the center. Do I add comments? Add comments. Okay, so I'll add a comment so I know this is like tutorial stuff. It's the character speed x second, and here we get the local. What did I write here? What's going on? The typing disorder, or the typing disorder. Dyslexia. Screen size, but no assignment. Game screen size, right? What? Size of game window. Okay, better, makes more sense. Game window size, window size, window size. And can I use the same logic everywhere to enclose this in a logical block section? For this, I'll just copy same code into R. Okay, this script here. Okay, don't do that. I'll add it here. Yeah, so is there save all? Where is the save all? Editor, save all, debug project, scene, save all scene, Control Shift Alt, mama. Where is the jump velocity used? Jump velocity function process, jump velocity. So what I'll do here, can I just comment all this stuff even for this guy? So comment everything, even having it like this all ready made available, so I don't need to handle all the warnings. We all know now so far who's to blame for all these warnings. Here I fixed it, move and slide, forget about it. Yeah. Now, that's all sorted out. So, what was that? Save all scenes, Control Shift Alt S. Are you sure? Control Shift Alt S. Yeah, that's all that's saved. Using the export keyword on the first variable speed allows us to set its value in the inspector. This can be handy for values that you want to be able to adjust, like a node's built-in properties. This can be, I repeat, this can be handy for values that you want to be able to adjust, like a node's built-in properties. Okay, cool, I got it. So it will reveal the, using the export allows us to set its value in the inspector, so that exposes it, like exporting it exposes it outside the script. Click on player node and you'll see the property now appears in the inspector in a new section with the name of the script. Remember, if you change the value here, it will override the value written in the script. If you're using C#, you need to rebuild the project assemblies whenever you want to see new export variables for signals. This build can be manually triggered by clicking a build button at the top of the editor. Hammer. Okay, so in the player GD, go out of the distraction free mode and in a player character player scene, speed 400 like mentioned. So if I click it, and this will override it. I don't want an override. What's the warning I'm getting? Where's the delta? For process, I've got still these functions. Okay, they have a pass, so I'll leave them as they are. I might also do the same trick and patch the character body 2D with a pass, do a pass patch for implemented to the generated functions. I'll leave the rest commented. Function, so this is all in this function definition, even the slide. So physics process is inside that function, in that method. Everything is, even move and slide. Okay, what's the tutorial saying? My player GD script should already contain a ready and process function. If you didn't select the default template above, create these functions. Okay, so that's the difference. In the previous step, attaching the script, if one uses the default provided script template for the parent node, it will create a default and add a methods provided with a template for a given node. And if one uses the template object empty, they won't be included. So the ready function is called when a node enters the scene tree, which is a good time to find the size of the game window. So we'll here get viewport rectangle size and store it to our screen size variable, which is global to the script, to the scene, but local to the project. Now we can use the process function to define what the player will do. Process called every frame. But okay, so implement this thingy for the player GD ready. Ready set. Do the screen size is I already forgot. Screen size is get viewport. Okay, get viewport. Get viewport pass nothing. Well, get viewport. Oh, that's rect size. Okay, get viewport rect size. Passing nothing size. Well, copy this. Go to character body 2D, and do we have here ready function? No, we don't. We don't have it on ready. I'm curious if this is extending character body 2D, what would be expected? So function ready, paste this, Control Shift Alt S, saved all. Ready screen size. Okay, now we can use process function to define what the player will do. Process is called every frame, and I've dealt with that in previous stream. So we'll use it to update elements of our game which we expect to change often. For the player, we need to do the following: check for input, moving the given direction, play the appropriate animation. First, we need to check for input though. Here I am. For this game, we have 4 direction inputs to check. Input actions are defined in the project settings under input map. Here you can define custom events and assign different keys, mouse events, or other inputs to them. For this game, we will map the arrow keys to the 4 directions. Click on project settings to open the project settings window, and click on the input map tab at the top. Type move right. Yep. Click add. we need to assign the key to this action. Click plus to open the event manager. The listening for input field should automatically be selected. Press the right key on the keyboard and menu should look like this now. Right, and move right. So okay, right keys now move right, move left, move. So it's move, left, right, up, down. Got it. I've dealt with that before. Input map, add new action, move up, enter, move down, enter, move your body left, move your character body right, up, plus, up, down, cursor keys, right? Well, no enter, up, down. I was hoping to confirm here selection with enter, but it is detecting it like a adding it to the mapping, so better not do that. Close, double check the tutorial. It should look like I did. Close button. We only mapped one key to each input action, but you can map multiple keys, joystick buttons or mouse button to the same input action. We can detect whether a key is pressed using input is action pressed, which returns true if it's pressed, or false. Well, guess what if it isn't? Descript. We start by setting velocity to O, O. By default, the player should not be moving. Then we check each input, so that's the vector 0. Is that vector 0? Start by setting the vector to 0. 0. So what I'm doing here is velocity x1, velocity -1, left, plus minus, y plus minus, up down. Okay. Y is plus minus, up is minus, down is plus, x is plus, left is minus. So going to the left, okay, to the everything going to the top left corner is minus direction, going down and right is plus. And is action pressed, okay. And initialize to vector 2, 0. Process delta, okay, in the process delta. Now let's code this. Coding. When you do it by hand, you're doing it right. So first, the maybe a bit more challenging bit is this now hacky solution by me and my buddy here, GD Doggy. Function process delta, yep. What you're seeing here is variable what's going on? No, everything is okay. So variable is the velocity, right? Equal vector 2d dot 0. And now we do all the checks, but let me double check implementing the velocity. the player movements vector velocity. So that's direction and speed. Okay. Why would the speed be changed? Because it's customizable in the engine settings. Is that the thing? Should I expose that in the implemented game settings options for in the user interface? Is there a default inbuilt default player speed? Yeah, there is. Character body, it has a inbuilt 300 speed 300. So we need to check for these 4 directions pressed. What if it's diagonal? Can this work diagonally? Both. Will this... Well, I guess it will... this will cover also 2 buttons pressed, plus adding and subtracting real time. Is pressed. Okay, okay. Input is action pressed. Right, okay, okay. X, Y, right, left, that's horizontal. Gotcha. So it says, I'll just make room for this if input, come on, don't input dot is action pressed. Is action pressed down, and I'll copy this. I'll just fix this with this and do it again, copy it again. 1, 2, 3 and a 4, because what I'm saying is up down. Don't correct me, just left, left, right. Stop it. I don't need suggestions right now. We are saying here that the velocity do I need to... No, I'm not growing it. I'm just... Do we grow the velocity? No, we don't. We say it is a... Wait. Yes, it does. Okay, XY plus equal 1. Okay, gotcha. So we do, so okay, move down, that's Y. That is Y axis, moving up and down, dot Y. Moving down is plus 1. So take this, copy for the Y-axis movement. Going up is minus, and for the X-axis going left is minus. While for going right is a plus. And I just copy all. So this is for our hacky version. Copy this, save this, and now in the player for the tutorial version script, in the process, we don't need the pass, hack, patch, shin. Indentation doesn't match what process? It matches perfectly, come on. What doesn't match what? Input. You don't know what you're talking. Save, let me double check if, okay, so here also somehow, somewhere, sometime, some point, somebody deleted an n in input, and so and what's at the bottom, move up velocity, if velocity length of what, if velocity length, okay, less than 0, less, greater than what, greater than 0, if it's greater than 0, velocity equals velocity normalized times speed animate sprite place. So let's see, is there explanation? Starting by velocity, moving when check each input, add, subtract from velocity, obtain a total direction. For example, if you hold right and down at the same time, the resulting velocity vector will be 1.1. In this case, since we're adding a horizontal and vertical movement, the player would move faster diagonally than if it just moved horizontally. We can prevent that if we normalize the velocity, which means we set its length to 1, then multiply by the desired speed. Velocity, okay, we can prevent that if we normalize the velocity, means set length to 1, then multiply by the desired speed. This means no more fast diagonal movement. Tip: if you've never used vector math before, or you need a refresher, you can see an explanation of vector usage in Godot's vector math. It's good to know, but won't be necessary for the rest of this tutorial. Vector math, that's good to know. Can I have that open in the new tab? Let's quickly double check that. New tab, vector math, where is that? Manual, best practices, troubleshooting, editor introduction, migration, 2D, 3D. So that's after the getting started. In the manual, best practices, troubleshooting, editor introduction, Android web editor, advanced features, migration to new versions, 2D, 3D, layers, viewport and canvas, transforms. There's quite a lot to actually play with here. And where is vector math, vector math. Cool, good to know.